What are ice sheets? Well, ice sheets are nothing but really big glaciers. And today we have two ice sheets on our planet, one covering the land in Greenland and one covering the land in the Antarctic. And these ice sheets consist of enormous amounts of ice. So for example, in the Antarctic, in some regions the ice is 5 kilometers thick. So if you stand on top of this ice and you were to drill down, you were to drill through 5 kilometers of ice before you hit the land underneath the bedrock. But where does all this ice come from? And so these ice sheets consist of nothing but really old snow. So you have to imagine in the polar regions it is so cold that the snow that falls in winter doesn't melt in summer. And so in the next winter, new snow can fall on top of the old snow, and that goes on for hundreds of thousands of years. The snow further down is pushed together by the snow further up. And so if you stand on top of such an ice sheet and you drill down, you make a journey through snow that fell last year, or 10 years ago, or 100 years ago, or 100,000 years ago, or 1 million years ago. And in this ice, you would still have the air inclusions that were embedded in the snow as it fell. And so from these ice cores, we can take samples of really old air, and we can also understand from the isotopic composition of the ice which temperatures were existing on this planet when the snow fell. And therefore, these ice sheets are incredible archives of past climate evolution of our planet. And so ice sheets are gaining mass by snowfall. And in order to remain stable, they also need to lose mass. And that happens through two mechanisms. One is simply melting of surface snow, surface ice, as the ice sheets get into lower regions towards their edges, and the surface meltwater then drains off and takes mass with it. Or, under its own weight, the ice sheets in Greenland and in the Antarctic, like any glacier, start flowing. So the ice is then no longer a solid body because it is so heavy that under its own weight it is pushed towards the edges. There it then drains out into the ocean, icebergs carve off at the edges, and by this mechanism the ice sheets also lose mass. And in equilibrium, the amount of mass that they lose through drainage, meltwater, runoff, and through icebergs equals the amount of snow that lands on these ice sheets. And in order to understand their magnitude, their size, maybe it's helpful to imagine that if all the ice in the Antarctic were to melt, global sea levels would rise by about 60 meters. If all the ice in Greenland were to melt, global sea level would rise by 7 meters. And so these two ice sheets really are the biggest reservoirs of fresh water that we have on our planet. When it comes to the changes that we observe in these two ice sheets, the major change really is a massive loss of ice over the past few decades. Overall, since the 1990s, our planet has lost about 40 trillion tons of ice because of the ongoing global warming. Just from these two ice sheets alone, at the moment, we lose every year 400 billion tons of ice. If we were to distribute that among the population of our planet, for each human there would be 50 tons of ice that are lost every single year. If we were to take this total mass of ice loss from 1 year and place it on a city like Berlin with an area of about 1,000 square kilometers, we would cover Berlin in about 400 to 500 meters of ice. And this ice loss is accelerating. Today, we lose about 400 gigatons of ice every year. Some 30 years ago, we only lost about 100 gigatons of ice every year. And this is the net ice loss. So it is the difference between how much mass we gain from snowfall and how much ice we lose by melting or by breaking off of icebergs. And if we look at these two processes individually, what we find that actually in some regions the snowfall is increasing because the warm air that we get from climate change can carry more moisture over these ice sheets. But this increase in snowfall is more than compensated by a massive increase in the loss of ice mass from melting and icebergs. And so overall, both ice sheets have been losing massive amounts of ice over the past few decades, and this ice loss is continuing. If we now look at the consequences of the loss of ice sheets, one consequence really stands out, namely the rise in global sea level. Whenever we lose ice in Greenland, whenever we lose ice in the Antarctic, This is ice that used to sit on land. But as we lose it, it will end up in the ocean either by meltwater or by icebergs carving off. And so we add water to the global oceans, which then in turn makes sea levels rise. At the moment, the two ice sheets in combination contribute about 1.5 millimeters of sea level rise every year, which is only about a third of the total sea level rise. And for the future, global sea level rise really will be dominated by the ice loss in Greenland and in the Antarctic. So if we talk about, for example, a sea level rise of potentially about a meter by the end of the century, most of this 1 meter sea level rise comes from these two ice sheets. So understanding the dynamics of ice sheets and its long-term evolution, and in particular the acceleration of the ice loss and its potential to become unstoppable in certain regions, really is key to understanding global sea level rise and the massive consequences that it will have, in particular in low-lying areas of our planet. If we now look at the question whether there are tipping points for these ice sheets, we first have to define what we actually mean by that. And so what we mean if an ice sheet has a tipping point, it means that at some level of global warming, the loss of ice from this ice sheet becomes unrelated to the amount of global warming. And so if we were to stop global warming, the ice loss would continue and become to some degree independent of this global warming. And we're pretty certain that tipping points exist for both ice sheets. The mechanisms for both are different, however. If we look at Greenland, the other tipping point that researchers have identified is primarily related to the fact that at the moment, the surface of Greenland is in a height of about 3 kilometers. Now, if we get a warmer climate, this surface will start melting, and so it will sink into lower air masses. And similar, as the air gets warmer as we walk down a mountain, also the surface of Greenland will end up in warmer air masses, which gives rise to more melting, which gives rise to further sinking into even warmer air masses. And even if we were to stop global warming, through this sinking into warmer air masses, this ice loss from Greenland might eventually become unstoppable. In the Antarctic, the tipping points that researchers have put most focus on are related to the fact that in the Antarctic, the amount of ice that is flowing out at the edges is related to the thickness of the ice in the regions where it becomes afloat. And now, because the bedrock at the bottom of the ice sheet is sloping downward towards the South Pole, as the warm seawater is eating away ice at the so-called grounding line where the ice becomes afloat, the ice thickness at this grounding line increases, which also means that the ice flow through this grounding line is increasing, which means that we are losing more ice. So the grounding line is retreating even further inland. And again, this ice loss eventually becomes unstoppable because this grounding line retreat then becomes the main mechanism rather than the warm seawater that started the retreat of the ice sheet. If we look at the Antarctic ice sheet as a whole, we are currently most concerned about this mechanism to start becoming active in some parts of the West Antarctic ice sheet, where there are some regions with a sea level potential, as we call it, of about 2 to 3 meters, where recent research has shown that we might be pretty close to crossing such a tipping point, which means that the loss of this ice will become unstoppable over the next centuries and millennia, and that maybe over the next few decades, we will be deciding on whether we start this mechanism or not. While it is clear that tipping points exist for the loss of the ice sheets, it is much less clear at which warming level they might be starting to be triggered. Some research has suggested that this might be the case at warming levels that we might reach within the next few decades, which means that within the next few decades, we will decide whether we lose ice from the Antarctic ice sheets for many centuries and millennia into the future, or whether we still have the chance to stop this ice loss.